There we go. All right, so it says here, suppose that P and Q represent the price of two phones. We know that P is bigger than Q because P is for a 64 gig phone and Q is for a 32 gig phone. From that, we are going to see what each of these dang things mean. And we're going to see if we can figure out which one's bigger. So sometimes it's easy if we know P is bigger than Q to think about it that way. So let's look at this one, P plus Q and 2Q. So if I buy a big phone and a little phone, I write a big P and a little Q, or I buy two little phones, which one's gonna cost more? Yeah, big phone, little phone. If I take a big one and a little one versus two little ones, this one's gonna be bigger. You guys can write in your books whatever the heck makes sense to your brain. But that's big phone, little phone versus two little phones. We know that side's bigger because P is bigger. Then let's look at the middle one. What do we think's going on here? P plus 1.08P and Q plus, P plus 0.8P and Q plus 0.8Q. What's going on here? Could we simplify this expression? If we think of this as 1P plus a bit of P, we simplify that. What do you think? If I have 1 pi plus 0.8 or 0.08 pies, can I combine it together? Yeah. To be 1.08 pies. And it's the same thing over here. I've got 1 quiche plus 0.08 quiches. So 1.08 quiches. Which one's going to be bigger? Remember, we know P is bigger than Q. So this side's going to be bigger, right? What they're trying to get you to see here is that for most states, 0.08, that's our with sales tax. So even if we include sales tax in the thought, P is still going to cost more. We know it's bigger. This last one's a little trickier because we've got 600 takeaway P or 600 takeaway Q. I know that P is bigger than Q. Does that mean that this expression is going to be bigger than this expression? What do you think? What happens if I take away a bigger number? Do I have more left? This one's asking about how much you will have left is a way to think about it. How much left after purchase? If I walk into the store with $600 and I buy the expensive phone, I will walk out with less money than if I buy the little phone. So in this case, this side's bigger. Okay, so we are going to be able to compare stuff even if I don't have values. I just know a relationship. Sometimes taking an expression and putting words with it helps us figure out what's going on. Hi. All right.
Give them till about the end of the week. If you haven't gotten an email yet for your dual credit class,
Okay.
let me know. The emails will start going through. Some of your kids may have taken
Right.
chemistry last year,
Right.
so they won't get an email to set up
their one
their
account.
accounts. Yeah.
Okay, so by the end of the week they should have their
Mhm.
account. Okay, cool.
And
Which
I can
means
find out
unit
what is-
0 we'll do next week. Is that what that
Well,
means?
Yeah, that's just honestly, if you look at it,
Uh.
that's just the enrollment.
Oh, okay.
I don't think it's anything beyond.
Beyond what
Yes.
they've already done.
Mhm.
Okay. I just hadn't looked at it yet. I'm like, too many things.
Because I've done it before, and it's just walking them through the steps is what it is. All you're
Okay.
doing is going over that PowerPoint is what they're calling that assignment 0. So if you want to do that with them, that PowerPoint with them, you can.
We don't have
What
much
period
time
do you
today.
have?
Third period.
I was like, if I'm not doing anything, I could run it through them so that they know. Because honestly, it doesn't take long
Right.
once they get started.
Once they get started.
It is about 24 hours before their account switches through, but they have till September.
Right. To get through there.
Yes. So we still have.
Cool. Thank you. Alrighty. So the next one we're going to look is test 7, so page 14. It's the same kind of vibe, but it's just a different situation. So we're going to do this too. Because we're looking at these expressions and seeing if we can figure out which one's bigger. And this time we are going to put it into words. What does this statement mean? The phone one, we were really just looking at the relationship. Now we're going to be putting things into words. So we've got X and Y is the number of male and female students. It says respectively. What that means is we've got that X is the men. And Y equals women because the data they pulled for this still exists upon the gender binary because this book was written 10 years ago. So here, what they know, we know that X is less than Y. There are fewer men than women at this particular university. So what we're asked to do is we are asked to figure out which of these is bigger. So the way that we can do that is we can take each of these statements and put it into words, and sometimes that's going to help us. Because X and Y, what that means, if I combine X and Y, well, X is Y and Y is women. Sorry, X is men and Y is women. If I combine X plus Y, that's men plus women. Or the number of students, it's the total. And the way we would put 2Y into words, that's twice the number of women. So which one's going to be bigger? The combined number of students or twice the number of women? Say it with confidence. I heard somebody say something. I just can't hear you. Which one's going to be bigger? if we know there are more women? Twice the number of women. This one's bigger. Because there's more women, twice the number of women is bigger than if I have to include some men. I'm going to give myself a little bit more space over here. There we go. So I have a little space to write over here. Because this one, it looks weird. It looks super complicated. Remember, X is men, so what this says is men over the total number of students. And this is women over the total number of students. So what this is really asking is this is really asking about the percent of men and the percent of women. So it's giving you a little bit more information. It looks weird and it looks complicated, but this is asking which one's more, the percent of men or the percent of women. It looks all mathy and weird, but it is the same thing. So which one's bigger, percent of men or percent of women? Percent of women, because they straight up tell us there's more women here. Thank you, my dear. I was going to say, you were in all your others. All right. Boop, 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 boop. There we go. Got you fixed. All right. So let's look at the next one. The last one on this page. And it's weird. This is weird. It looks weird. It feels weird. So what this is the difference between men and women and it's divided by 2, or it's in half. And this one is exactly the same one as above. This was the percent of men. Is that easy to compare those two pieces of information? Is it percent versus percent? Or the difference or the sum compared with something similar? Is that easy to compare? No, right? That's gross. One thing we can see if we stop looking at this in terms of people. Remember what we said, X is bigger than Y. Or Y is bigger than X. Sorry, I said it backwards. Y is bigger than X. If Y is bigger than X, and I take Y away from X, is that going to be a positive number or a negative number? X minus Y. And remember, Y is bigger. It's going to be negative. X minus Y is negative. Because Y is bigger, right? Is the percent of men going to be negative? Is this going to be negative? No, because I can't have a negative percent, right? So since this piece is negative, we can tell the difference. So sometimes the context doesn't help. Sometimes it does. When we were comparing percent of men to percent of women, that's a whole lot easier to think about. But sometimes it doesn't help. And we have to look at it as an expression. It's just kind of weird. Okay? So I want you, actually no, we'll do the next page together, but I need y'all to talk more. So we're gonna look at page 15. And we're going to think about which of these would be bigger. The goal is to do it without substituting in values. But if we need to pick something in tests, that's the way we do it. Okay? So it says to do it without substituting specific values. If you choose to test things with substituting, you cannot use, see, I'll write it down. Zero, 1, or 2. Ever. When we are testing things to see if they're equivalent, we cannot use 0, 1, or 2. Because 0 times anything is what? 0. That doesn't help. 1 times anything is just whatever that was. And 2 has a couple of specific situations where we can't tell what's going on. Because what is 2 squared? What's 2 squared? 4. What's 2 times 2? What's 2 plus 2? So will it help me with the, is it equivalent? Because all those operations, you get the same exact answer. So if we choose to do things with testing values, because I'd rather us test than give up, don't use 0, 1, or 2. You use anything else in the existence of the world, except for those 3. Okay? So we're going to look at some of these expressions, and if you choose to do it with testing, that's fine. I'd rather us test than not test, than not answer. But we can also look at these critically and think about it. So let's start with this first one, 5 plus t squared and 3 minus t squared. So when we think about something like t squared, any number when squared, I don't care if it's -4, +50, -1,000,000, whatever. When we square something, are we ever going to get a negative number? No. So t squared is always positive. Whenever something is squared, it's positive. So then we have 5 plus something and 3 minus something. Which one's bigger? 5 plus something will always be bigger than 3 take away something. So 5 plus t squared is bigger than 3 minus t squared, okay? So this looks weird and complicated and it looks gross. When you break it down into little bitty pieces, it's not too awful, right? It looks gross. It looks super complicated and algebraically and like super gross. Are we gonna have to factor? Not yet. Okay. So then let's look at this one. We've got fractions. Gross. We hate fractions. Ugh. I know how it goes. We hate fractions. Ugh. So there's only variables in the denominator. Let's look at these denominators. I've got something squared plus 6 and something squared plus 7. Which one's bigger? Plus 7. Because it's always a positive number, right? I mean, even if it wasn't, it still makes the right side bigger. So if my denominator is bigger, so the bottom number is bigger, which expression is bigger? Think of pizzas. Which denominator is bigger? The 4. Which slice is bigger?
Wait, oh, no, it's half.
Half. Right? So if the denominator is bigger, which expression is bigger? Right or left? Left. So my denominator is bigger, but my slice is bigger here. Okay? So if the denominator is bigger on the right, my slice is bigger. So this expression. So when we're comparing, sometimes it helps to look at littler pieces first. Two more of these. I'm not going to make you try them on their own because they're kind of gross looking. They look scary. They look super scary. But remember, all we're saying is which one's bigger. I'm not asking you to multiply it out. I'm not asking you to do anything crazy with it. It looks gross. There's all kinds of squares and blah. But all I care is which one's bigger. Left or right? What do you think? What makes you think left's bigger? See, I'm just giving it colors. So blue and purple. If it helps, plug in a value. Pick something for S. Maybe S is 5. Maybe S is -2. Probably shouldn't use 2. Maybe S is 3. Plug it in and test it. See what happens. What do we think? Which one's going to be bigger, blue or purple? We have something plus 2 and something plus 1. Or something plus 4 and something plus 3. Plus 4 and plus 3. Because other than that, these expressions are the dang same. The right side is going to be bigger. It's bigger. We are going to need to be able to look at stuff and kind of estimate which one's bigger. That is going to come up again and again and again and again on things like tests and or finals. Just as a quick word of warning, the final in the spring for this course is the year-long final. Like, it'll be over everything from now until May for the spring final. It's a year-long final, and it's set by the state, and I cannot change it. We will have a final, but it's going to be like just the semester test. The spring final, which is set by the state, which allows us to do the credit thing that we need to for college, is a year-long final. So it's going to include everything, including stuff from this chapter. We'll review. I'm not going to just like toss you to the wolves. We'll go through it, but just saying. Just saying. We might want to be able to tell if there's a bigger one on one side than the other. This last one I think is probably the hardest. I've got 8 divided by something or something. Which one is going to be bigger? For the most part, the second one's going to be bigger. There's an argument to be made if the if this piece is less than about 2.5, this is bigger, but for the most part, this side's gonna be bigger. There is gonna be a time when 8 over something squared plus 2 exactly equals this. And we could solve for that. There is a time when that happens. The solving for it is kind of gross. But it happens. But for the most part, that's going to be bigger because I'm saying, all right, 8 divided into 20 pieces would be less than 20. 8 divided into 4 pieces would be less than 4. But 8 divided into 2 pieces would not be less than 2. So sometimes we're going to have to think about things in different ways, or try and put them into words, or plug in values. You can test these with numbers. If you substituted in 3 for k, you would get this one bigger. If you substituted in 5 for k, this one's bigger. If you substituted in 12 for k, this one's bigger. If you substituted -3 in for k, this one's bigger. So there's only very few specific instances where it's less than. And for the most part, this one's going to be bigger. So you can always test these by plugging things in, just not 0, 1, or 2. You may not test things with 0, 1, or 2 because those 3 like to play tricks. You can use a half. I don't care if you use stuff in between. 1.5, who hurt you, but you can do it. Why would you torture yourself with decimals? You can. You're not wrong. You're fine. Just why? Use 3. Use 5. Use 4. I don't care. Test things. You don't have to just do it by sight. If you can, great. If not, test the suckers. Okay? Substitute in values. Questions on any of these? We went through a bunch of pages today. Being able to kind of look at expressions and see if we can figure out which one's bigger is going to be one of those things that we want to look at. Okay? We're going to start working on doing some pattern recognition and working on starting to build equations from pictures and stories and sentences and stuff like that over the next few days. There is not a homework today. You're going to have one homework this week, and it'll be Wednesday, or due Wednesday. So we'll talk about it tomorrow. Actually, I think it's more due Thursday. But, we'll flex it. Because what we're going to do tomorrow and Wednesday will both be relevant for that homework. It's all about patterns and pattern recognition. If you want to look at it, you can. I always have them set so that you can look at them early if you want to. More power to you. And you can do homeworks as many times as you want to. So if you want to try it, submit it, and then try it again, that's fine. You can always get more points that way. Our first chapter test is going to be August 25th. We're about 2 weeks away. Less than 2 weeks away. Okay? That is all I got for you today. You have 12 minutes left in class. Rock on.